I'm Michaela. I host Hardware Meetup New Zealand. Can anyone put up their hand if they've been to a Hardware Meetup event before? Oh, that's actually quite a lot. We did run one event here last year in Christchurch, so great to see a lot of familiar faces. So if you haven't been to any of our events before, we've been running since 2016, and we're all about bringing people together to showcase amazing companies working in different areas of the hardware space. So yeah, we have a pretty standard format that we always follow. We have 3 speakers, which are half an hour each. The first 15 minutes is just a kind of sit down fireside discussion with me and each speaker, and then we'll open up to 15 minutes of Q&A with the audience. So we couldn't be running this event without our amazing sponsors. First, we'll have Epic.
Hi guys, I'm Henry. I'm the Partnerships Manager here at Epic. If you don't know, Epic is an innovation centre. We're home to 15 different companies of a wide range of industries. We've got gaming firms, we've got SaaS companies, sales, marketing, basically, whole mixed bag, as well as housing tenants. We also host events like this. It's awesome to support the local community and try to get as many of these going. As well, we have event space, meeting rooms for hire, that sort of thing as well. Speak of space, we do actually have space available at the moment, so if you're looking for space for your company, please come chat to me afterwards. That'd be awesome. And yeah, or if you just want to learn more about the space, come say hi. And I might steal the spot for also there. Very exciting. Awesome. Perfect. Thank you so much.
Sweet, thank you, Henry. And next up, we'll have GPC.
GPC Electronics, based in Christchurch and originally based in Penrith, Sydney. We are a contract manufacturer with 2 SMT lines and with box build capacity also, and willing to help you out with all your hardware solutions.
Awesome.
Quick enough?
Yep, excellent. Thank you very much. Next up, Aerospace New Zealand. So yeah, this is a partnership event with Aerospace New Zealand.
Kia ora koutou everyone. Lovely to see you all here this evening. My name is Bridie Gibbons. I'm the Operations Lead at Aerospace New Zealand. Hopefully some of you know who we are, but we're the industry body for the aerospace sector, so that is for space and advanced aviation. We run very similar events like the team here from Hardware Meetup New Zealand. We run Meetups, and we also run the New Zealand Aerospace Summit, which some of you may have been to or heard of. It's a pleasure to be supporting Hardware Meetup here tonight, and fingers crossed it is the first of many events. If you'd like to come and have a chat or join our Associates program, please feel free to come and have a chat with me at the end of the event. Thank you.
And that's Loon Digital.
My name's Clinton Williams, and I've recently joined Loon as their Business Development Advisor. Who's Loon? We're an engineering consultancy firm based in Auckland who work in across the embedded system space. Effectively, if it's got a camera, if it's an optical sensor, edge processing, RF communications, small, low power, that's in our wheelhouse, and that's what we do. Our ambition is we're going to space. We're going to take these technologies that we have and our capabilities, and we're going to move towards the space sector and help other New Zealand companies in a collaborative fashion to solve some of the problems facing our country at the moment. And so if you want to talk, if you want to work in the space sector as well, if you want to get on this train, come find us afterwards and have a chat. We'd love to talk. Thank you.
Thanks. And we also have Christchurch, New Zealand.
Hi, for those of you who don't know me, I'm Damien. I look after the New Zealand team for Invinio. So it's my pleasure and privilege to sponsor the hardware team again. We've done it a few times. So Invinio, we're a technology partner for the manufacturing industry. So we're both a software and hardware supplier. So we help our customers reduce the friction from design through to production. And we supply software tools such as SolidWorks, CATIA, Innovia, Simulia, Abacus, simulation tools, and help people use and make the most out of those. And on the hardware front, we supply additive machines from Markforged and 3D scanners from Arctic 3D. We do have a few of our customers in the room, from Dawn through to Southern Spars, Kia. In fact, actually, we do have options for both startups and established businesses. So if there are people who are looking for help as a startup business, we have the ability to offer free licenses and discounted licenses for those startup companies. But yeah, thank you very much.
Awesome, thank you. Thank you for joining me, Mark.
Thank you.
So could you tell me about what Kia Aerospace does?
Yeah. Hi, everyone. Does anyone know anything about Kia Aerospace? Anyone heard a little bit? Okay, so cool. Basically, we build solar-powered aircraft that fly in the stratosphere. And the reason we want to fly in the stratosphere is because we are going to be flying above the weather and also above other air traffic. So it's in a kind of sweet spot between satellites and lower altitude aircraft. So by the stratosphere, I mean you've got the troposphere and then the stratosphere. We'll be flying at about 20 kilometres altitude, about 60 to 65,000 feet. So for a bit of context, when you're flying to the US, it's about, say, 38, 40,000 feet. So about another third higher. So yeah, great place to fly. A few small problems with it though. You've only got about 10% of the air density up there. So it means it's a bit harder to fly. And it's really a battle against mass and also energy efficiency. So you've got to build these really light aircraft that are really energy efficient. So yeah, that's what we've been working on the last few years. Here we go. So yeah, the first kind of problem that we're tackling is around maritime domain awareness. And so we'll be working to solve problems such as illegal fishing, illegal immigration. There's a little bit of feedback going. Maybe. Yep, very good. And drug smuggling. We get a whole lot of boats dropping off the drugs, which, if you like drugs, that's great. But if you but yeah, I don't think the government is that keen on the amount of drugs that are being dropped off at our shores. So yeah, quite keen to help the government solve that problem. And also we get a few warships that come through and visit us from other countries, like the ones this year that came through the Tasman Sea. So yeah, basically maritime domain awareness is a big one, and we've got about 20% of the ocean area in the world. So definitely a problem worth tackling. But yeah, were you going to ask some questions, or am I just going to keep talking?
I think go over your next slide and then we'll keep going. Yeah.
Okay, cool.
So yeah, tell us about exactly what your solution is.
Yeah, so at the moment we're building the Mark 1, which is a dawn to dusk type aircraft. It's a one-day flight time aircraft, and it'll get up to stratospheric altitudes. We flew to 56,000 feet into the stratosphere. We're actually all ready to get a flight test going over 60,000 feet. We've just been waiting for a good weather day. Canterbury's a great place to do manufacturing, as we all know, but the weather can be a little bit iffy. And in spring, we've only had about one flight day that we could have actually flown. And unfortunately, it was between missions where we'd sort of given up on one mission and thought, okay, we'll get ready for the next one. And then this bloody good day weather came along and we missed being able to fly. So yeah, we've actually got a couple of people from the German Aerospace team here. We've got a camera payload from Germany that we're aiming to fly up to the stratosphere, up to 60,000 feet. So yeah, we're just sort of waiting for that. Really, what we can do with the Mark II, the next version of the aircraft that we're designing at the moment, is to fly continuously for weeks or months at a time. And that's really where I fell in love with the concept of these solar-powered stratospheric aircraft that can fly continuously for weeks or months. I love space hardware, love rockets, love that whole thing. But yeah, I just think it's a really compelling scenario to have these solar-powered aircraft that can fly continuously. So really that, you think about satellites that go from horizon to horizon in about 8 minutes. They can't stay on station. You've got to have a whole fleet of kind of Elon Musk type satellites, which you might use for telecommunications. But for Earth observation, it's difficult to find days continuously where you don't have clouds or other stuff going on. So yeah, the fact that we can stay over a city or over an area for as long as required is a kind of unique selling point that other platforms don't have. Obviously, being solar powered means we don't use avgas or rocket fuel, and being 20 times closer to the ground than satellites, it means that we can get much higher resolution.
Yeah. Awesome. So yeah, how do you make these aircrafts, and how do they work besides solar power?
Yeah, so we basically have a manufacturing facility in Iverson Terrace, not too far away from here, and essentially it's composite materials. So we have a CNC machine where we make the molds, and then we have a composites room where we basically use Kevlar or composite materials, lay it out in the molds, and then try and build, really light aircraft. We bring in a few materials such as solar cells and batteries and electric motors from the US, but we try and do a lot of the manufacturing here in Christchurch. And really a lot of the problem that we're solving is like an integration problem. There's a whole lot of different technologies that you've got to integrate in the right way to kind of find that sweet spot. So we've got a few competitors around the world, and they're kind of building different types of platforms. We look at Airbus, that they've actually really proven the concept. They flew for 67 days continuously in the stratosphere, which is pretty impressive. But they've sort of built a Ferrari, and each one of their platforms is very expensive, using the sort of top grade solar cells and batteries. We're trying to build more of a Toyota, Tesla type aircraft, which is a lot more affordable. So instead of having one aircraft, we might have 10 of these aircraft that can cover much broader areas with different payloads.
Do you want to go into a bit more technical detail about some of those smaller components?
Yeah. So you look at the Mark 1 aircraft, it's about a 12.5 metre wingspan, under 40 kgs, and the next version will be about a 30 plus metre wingspan, about 150 kgs. So if we look at comparison, a Boeing P-8 aircraft, so New Zealand bought 4 of these submarine hunters, these Boeing aircraft, about $2 billion the New Zealand government paid to the US Boeing team to buy this aircraft, and they're about 65,000 kgs. So a lot of manufacturing goes into those big boys. Our Mark II will be about 150 kgs. So even from the manufacturing process, it's a whole different scenario. And we'll be looking to take up about 5 or 6 kgs of payload. The current Mark 1 is about 2 kgs of payload, and hopefully it'll be about 150 kgs if we can try and keep it as light as we can.
Excellent, cool. And you also had a payload slide as well? Cool. Yep.
Very good.
Cool.
Excellent. We've got the German Aerospace Centre team, the DLR team here with their multispectral camera. The very good optical system. The next version for the Mark II will be even higher resolution. So at the moment, we'll probably get to about 70 centimetres per pixel for an RGB Google Maps type image. But the next version will be about 15 centimetres per pixel, maybe 6 to 10 bands. So you've got those RGB plus infrared through to ultraviolet, so really super high resolution. And we're also excited about the DLR synthetic aperture radar system. So the great thing about SAR is it can look through clouds, can look through weather, can operate at night time. So it kind of changes the game. So obviously if you are you're trying to go for those Google Maps type images, you've got to have a day where there's not too many clouds, and that's not always possible in the land of the long white cloud. So having synthetic aperture radar is fantastic for nighttime. So it could be great if there is a weather event, you could actually fly over that weather event and detect when there's bridges or infrastructure, and feed that back to responders on the ground way more quickly than what we can do at the moment.
Awesome. And could you give us a bit of a journey on how you, the start of your career journey, and then how that led into Kia?
Yeah, so I basically just did a bit of an OE with a guitar on my back around Europe, and I was going to go to university, but I didn't quite make it. So I actually was a bit of a musician. And actually, I had a band called Planet Blue, which is pretty cool. And I ended up being actively unemployed as a musician, and became eligible for a job subsidy. And I turned up at this internet company back in 1994, and the company was called Planet. And I was in this rock band, Planet Blue, and the manager thought that was super cool, that he was into synchronicity and he's a bit of a hippie. Basically I got my first break, and that was my first kind of office job, being the sort of front desk kind of guy, showing people how to use email and the Mosaic web browser and Netscape and all those good times. Some of you might remember those early days of the internet. And then in 1998, I started an internet company called Avatar, and it's great. We've got a few Weta Workshop people here talking about the new Avatar movie coming out next week. That's pretty soon. It was kind of a sci-fi logo. There's a bit of a theme here. You probably noticed there's some science fiction stuff going through my life here. But and started Avatar, and then a company called New Zealand Tourism Online. I sold that to Telecom, and that put a bit of money in my bank account, and decided to follow my dream of aerospace. And I ended up being seed investor of Rocket Lab in 2007, and then in 2018 started to think about developing a company here in the South Island, and that's Kia Aerospace, and really, really thrilled to be doing what I'm doing.
Awesome. That is the most interesting career journey I've ever gotten when I've asked that question.
Yeah. Well, that's the kind of short version. There's a lot more to it.
You could be here for an hour.
Yeah.
Should have your own show just where you just go through it. Excellent. Awesome. And what's the future for Kia shaping up to look like so far?
Yeah, well, we're just sort of doing a funding round for the Mark II program at the moment, and we're getting some good signals, just trying to lock in our lead investor, hopefully in the next few days, and got a bunch of other people that are interested, so fingers crossed, touch wood, that all goes well. And then, we've just started the design phase of the Mark II, and that's going to be really exciting. We've got to the stratosphere with the Mark I, but to build an aircraft that can fly up there for weeks or months continuously I'm just super excited about it. And also, starting to work with more customers. We've got a few customers we're working with, but to have those payload flights, working with those customers is pretty exciting.
Awesome. And last of all, is there anything the audience can do to help you out today?
I don't know. I mean, maybe come to the Christmas party. We've got the Aerospace. We've got the Aerospace New Zealand Christmas party. So if you want to hang out with a few aerospace geeks and a few, it's a bit of a dress up as well. There's a prize for the best dressed. So get your craziest sci-fi outfit on. So that's Tuesday at the Ducks. But if you go to Aerospace New Zealand, you'll be able to buy some tickets. It is a pretty cool party, and I highly recommend it. You'll have fun.
Awesome. I made a light-up dress, but unfortunately I won't be in Christchurch then, so
okay.
that's pretty sci-fi, I'd say. But Awesome, cool. Thank you very much, Mark.
Thank you. Are we going to do Q&A?
Oh, yes, we will. Let's clap first, because this is what we always do. What is the Kia business model?
Yeah, so we'll start off leasing the aircraft out to strategic kind of people, and for example, the New Zealand government. That'll be for the maritime domain awareness. And we've got other companies that we're leasing the aircraft out to. That's sort of phase 1, phase 2, but phase 3 is when we're actually moving into more of a data model. And if you kind of think of SpaceX and Starlink, they've sort of moved to that sort of data model, and ultimately we'll be capturing huge amounts of data over large areas. So we'll be working with geospatial companies and hopefully providing them with a whole heap of data.
Awesome. We have 10 minutes for questions, so because the cellular data is being an issue, if you have a big question you want to ask, maybe come stand up at the front here. There is Wi-Fi on the board as well that you can look at as well. Cool. But if you have a burning question you really want to ask, you can come up over here. Sweet. What do you think is the next steps in building out New Zealand's aerospace industry?
Yeah, I think we've got a really great opportunity in New Zealand to build on the successes that we've already had. And, the reality is Rocket Lab is the kind of poster child of what's possible in New Zealand. When we started Rocket Lab in 2007, it was, Peter and I, a couple of crazy guys that love space stuff, and had this dream to build a space rocket company, a space launch company in New Zealand. And if you kind of look at it, the 10 other orbital spacefaring nations in the world all had massive expenditure from military government projects, whereas New Zealand, we don't have hardly any kind of military or research capability in that missile or rocketry kind of area. So it didn't kind of make sense for New Zealand to have that orbital spacefaring nation. As an example, we had 4 frigates, now we've only got 3 because we sunk one of them. We just don't have very much in that defence realm spending. So it's pretty cool that Rocket Lab has really benefited from a commercial approach, as opposed to a lot of those countries. it's kind of like having the gorilla in the corner of the room. You know, everyone sort of gravitates toward that, whereas having that blank piece of paper and really focusing on the commercial opportunities, I think is an interesting scenario. So, yeah, it created a hindrance, but it also created an opportunity. And really what New Zealand needs to do is to create 10 rocket labs. And we're kind of seeing the sort of budding seeds of the flowering of that. If you look at companies like Dawn Aerospace and Kia and SBS, and there's a whole bunch of these companies that are starting to kind of build momentum. And what I'd really love to see is 10 plus aerospace companies really building up. And really, the aerospace industry internationally is such a huge, massive industry. We don't need a large slice of that pie. I think if we sell ourselves as a great manufacturing hub, a great R&D test area, a lot of those countries in the Northern Hemisphere have a lot of high population, they have a lot of air traffic, they can't do a lot of that testing, so New Zealand could really sell itself as a great R&D test area for the world. We've got this big Pacific Ocean right out in front of us, we've got low population density, we've got hardly any air traffic. And if we look at the Te Whāki National Aerospace Centre, which I think you're going to be hearing a little bit more about,
Yep.
That's such a fantastic asset for the region and for the country. And, we need to develop more of those test bedding type opportunities around New Zealand. So, what we're aiming to do at Aerospace New Zealand, I'm also on the committee of Aerospace New Zealand, is to kind of connect people, tell the story. A lot of New Zealanders don't even really realise that there is an aerospace industry. But if you look back 20, 30 years ago, people wouldn't have thought that we have this amazing filmmaking industry. We have boat building, we have winemaking. We're really picking niches that are doing incredibly well. And, aerospace, can be a bigger part of our economy in the future. We don't need a huge part of the international pie. We just need a little small percentage, and that will be pretty great for the country.
Definitely. How do you launch, and how long does it take to get to altitude?
Yeah, so at the moment with our one-day aircraft, we basically just circle up, so launching from the roof of a car. If you go to YouTube and type in Kia Aerospace, you'll see some flights there. Essentially just circle up. It really depends on the weather. I guess that's one of the sensitive things. Building this super light aircraft that is incredibly energy efficient. It's about picking the good weather days. So we really need quite light weather, wind conditions. So it could take 4 or 5 hours for us to get up to 50,000+ feet. But coming down, we can get down within an hour or two if we're sort of punching down pretty quickly. So really, when we are up there, we're then worried about trying to find a weather window where we can come down again, where there's not too many kind of gusts and side winds. We'll try and pick that time to come down, and then make sure we get down safely. I mean, obviously it's better to come down in one piece as opposed to multiple pieces.
How many have ended up in multiple pieces?
Touch wood, none yet. But we've got 2 Kia Atmos Mark 1s, so we've got a backup ready to go. The reality is some of our competitors have had days where they've had the aircraft come down in more than one piece. So, but that's the nature of what we're doing. We're building these super light aircraft. We're really pushing the limits, and they're not designed to be kind of Spitfires doing these aerobatic manoeuvres. They're designed for relatively stable conditions.
Yep. I have time for 2 more questions, so please vote. Were there any big learnings or mistakes which you can take about from building MK1? The screen's at an awkward angle.
Yeah, I mean, it's always a tricky thing trying to get the manufacturing processes right. We basically built a team from scratch. I think I'm pretty happy where we got to. There's probably some areas we could have moved a little bit faster, but overall, I mean, it's a tricky question to answer. I mean, it's kind of like you have that crystal ball and you look back and you think, oh, that was a mistake, but then it actually turned into a learning kind of process. So, I don't know. That's a tricky one to answer.
That's okay. You mentioned the challenges launching the plane. You mentioned the challenges launching the plane with regard to weather. How are you looking to combat that? The MK2 has a longer flight time. Is there anything else?
Yeah, obviously, if we can build the aircraft to be a little bit more robust, that is going to be something that we can try and do. But again, you're battling to try and reduce the mass, so there's a whole lot of tension points. You know, if you want to build it, say, 4 times tougher than you really need it, but that's going to add more mass. So it's a real balancing act to try and find that sweet spot.
Awesome. And last question. I feel like you kind of answered the what makes New Zealand special for space exploration already. Is there anything else to add to that?
Well, there's an interesting one there about nuclear energy. Yeah, I think that might make things a little bit heavier. But yeah, there is a scenario. Yeah, actually, I just came back from New York where I had a meeting with the HAPS Alliance, and that's essentially a lot of our competitors. And people were talking about the projects that they were doing, lots of different aircraft, and big giant blimps the size of football stadiums. It was quite fascinating. But yeah, there was some people were talking about hydrogen high altitude systems, and they're not designed to fly for months continuously, but they could be designed to fly for a week. So hydrogen could be an interesting scenario. Make the aircraft a lot heavier. It would be a whole different design. But it would enable you to fly larger payloads and maybe build the aircraft to be a little bit tougher. So yeah, I think a hydrogen HAPS could be an interesting scenario.
Awesome. Cool. I think that's all that we have time for today. But yeah, thank you so much for joining us today. It's been great to hear about everything.
Thank you.
And next, we're going to welcome up John from Tawhaki. Awesome. Thank you for joining me.
Thank you.
Could you tell me a bit about what Tawhaki does?
Yeah, so first, kia ora koutou te whānau, ko te man tōku ongoa. To start with what we do, I like to kind of introduce who we are, I guess, and what we are, because we're not kind of commercial entity in the conventional sense. So just got a wee slide here of our shareholding. Nice, interesting way to start, but we're novel. We're a 50% shareholding between the Crown, New Zealand Crown, and the 2 local runanga to a piece of whenua, a piece of land called Kaitariti, and that's Wairiwa and Te Tamutu. Where am I pointing this?
Just point at him instead.
Click. Yeah. So this is a bit of a kind of geographic picture here where you can see Kaitariti down at the bottom. It's a really significant piece of land. It was an ancient trail. So back pre-European settlement, this was the highway of the south. The 2 local runanga, Tamutu and Wairiwa, kind of bookend the landmass there, where Tamutu are on the west and Wairiwa are Little River to the east. We've currently got a land holding of 1,000 hectares, but it is important to note that the runanga are mana whenua to Kaitariti, so customary stewards. So what do? This is a very kind of 30,000 foot view, I guess, of what we do, and hopefully I'll kind of peel back the onion as we go forward. But we've got a dual co-pupper, which is kind of, I guess, a flow-down effect of having that mixed shareholding. So the first, and certainly the most important to the Maori ownership, is to heal and rejuvenate the unique whenua at Kaitariti. There's been a lot of change over the last, let's say, 140 to 150 years. Basically, the Lake Ellesmere that was to the north of that picture got drained for agricultural land, and over time, the whole area has been transformed for agriculture. And that's completely affected the endemic species and the significant flora and fauna at Kaitariti. On top of that, mana whenua have essentially been cut out from that land. So when we talk about healing and rejuvenation, we're not just talking about ecology and the environmental side, although that is very important. We're actually talking about reconnecting people to place. And I'm not really going to talk too much more about that side of our kaupapa, but it's really important because it underpins everything we do, and it really kind of knits together, I guess, with the aerospace side, and it enables what we're doing on the aerospace side. It's a nice little high-level goal there for the aerospace. So, yeah, what we do on the aerospace side is we try to advance Aotearoa's aerospace industry. So, not too much, really. Yeah,
No,
nice
nothing at all.
Yeah.
So easy.
I'll pause there. Yeah.
Cool. Awesome. And yeah, so you guys have a facility.
Yeah.
So yeah, how do you run this facility and like how does it all work?
Yeah, how does it work? I'm gonna go back a step to what's it for, I guess. It's kind of related to what we do, but this is a very complicated graphic, kindly provided by NASA. I did ask. This is a bit of a picture of the future state of aerospace. And I think the important thing to note really is that it's completely different. You know, that's the nuts and bolts of it, right? I'll do a bit of an audience participation. So hands up if you've taken a flight in the last, 5 years. We'll try and capture as many people as possible.
Today.
Pretty good, pretty good. Keep your hands up. Yeah, come on guys, keep your hands up. Keep your hands up if you felt safe when you were on your aeroplane. A couple dropped there, so maybe some Jetstar, I'm not sure. No, just joking. The reason for that is because there's 70 years worth of rules and regulations and lessons learned and technology development that's gone into the current system. That's all changing, and essentially it's driven by technology, it's driven by different propulsion systems, it's driven by a significant level of autonomy, it's driven a lot by, as you heard from Mark with what Kira doing, people coming out of the aeroplane. I'm not going to go into all the kind of detailed applications, although there are many. But
that's basically like the future of like what we want to get to, right?
Absolutely, yeah. So great question as to when. I don't think anyone really knows that, but there are some massive gaps from where we are now to there, and that really is kind of what TAFC is for, right? From the aerospace side, we're here to try and facilitate that change and support that transition. So we talk about it in kind of 4 buckets. We've got policy and regulation, the exciting stuff, but that's actually really what lets everything fly. That's why all your hands stayed up when I said, do you feel safe? Would your hand still have stayed up if I said, okay, take the pilot out of the aircraft, throw some DJI drones up at the same time, that you can see out the window, drop down vertically into your vertiport on top of a building, all those kind of things, right? That's where we're going. And it's happening. It's not that this is miles away, this is happening. So policy and regulation needs to vastly change to enable all of that. Airspace integration can't happen until the policy and regulations are there, but you can't go from what we've got now all the way to this massive integrated system. Yep. You've got to stepstone your way there, and that's a big reason for a facility like TAFC, and that there may be more in the future. But you've got to go and provide the CAA and other people involved in the policy making and the regulation with data to say, hey, what rules make sense? You prototype, right? You prototype and you test, but you're not going to go and do that next to an Air New Zealand commercial flight down to Dunedin. Critical infrastructure also could potentially completely change. So you probably think of runways and airports and that kind of thing, and I mentioned the idea of a vertiport, which is adjacent, but then actually, to me, there is some physical infrastructure change, probably from the energy perspective mostly, but the digital infrastructure side is really where the hard transition is. So a lot of stuff kind of behind the scenes with the current system is where a lot of the tech is. If you look at what Airways are doing, that's our ANSP, Air Navigation Service Provider. They have a network of radar systems. The primary surveillance is tracking all the aircraft. It's designed to track commercial size aircraft. ATC have their towers and their other rooms where they're monitoring all these aircraft, and there's a whole software stack behind that to manage it. They're talking to all the pilots with radio systems, literally airband radios, a person to a person. That's all got to get upended and kind of reimagined, I guess.
Because right now people are very integrated into the loop, right? And to get
100%,
a system that big, you still need people, but yeah.
Yeah, I mean, look, I think you'll need people for a long time, and that's part of that kind of transition through, which is kind of, I guess, the next bucket of what are the skills that we need to develop. But yeah, the long-term view is that autonomy takes a lot of that burden, and that's where kind of scales of efficiency come in, and you just enable different types of applications. But trying to go from what we've got now to that future state at the scale of an air navigation service provider in just a single country is exceptionally hard. But then thinking about it that this is actually a global problem, you know. You've got to try and standardize. If you can't standardize, you've got to start to test and prototype in a way that you think is aligned with where other people are going, and people usually look to the likes of the FAA and EASA in Europe, because they're the kind of the larger sectors that are the credible systems. So it's just, it's hard, right?
Yeah.
And then the last bucket there, which is probably the most important, is the people side, and we kind of touched on it, but this isn't going to happen. You know, AI is not quite there yet. I don't know what Elon's up to with Grok, but I don't think they've quite figured that out. So there's a whole new kind of skill set required for this, right? If you talk to Scott or Mark, just to throw you under the bus there, guys, ask them the size of their teams that run the aircraft. You know, well, maybe not Scott's actually, but Mark certainly. It's a big operation, particularly in the kind of R&D phase, and then when you kind of flow that down through the rest of the system, we've got to retrain air traffic controllers. What do pilots look like in the future? What does supply chain look like? What does maintenance look like? And all this kind of adjacent activity.
And your rapid iterations don't really fit very well into this whole process, do they?
Well, regulators don't like rapid iterations.
Yes.
Can I say that? Are there any in the room? No. Yeah, so like it's just a really big job. So wrapping all that up to, I guess, how it works, we kind of try and play a facilitative role and then also provide some infrastructure to do that. So I think I've got a couple of slides here on what we've got. So right now, we've got the Tavki National Aerospace Centre. That's kind of in the middle of Kaitareiti, pretty much bang in the middle. It's a 100-hectare site. We've got a kilometre-long runway, you can see there, a 600-square-metre hangar called Faitiri, which, if you're interested in some of the etymology, that was Tavki's grandmother. Some of the other more interesting things, we've got some digital infrastructure starting to come in, and I won't talk too much about that right now, but we've got radar systems, airborne radios, ground radios, we've got detection radars, and we've got some MET, stands for meteorological there, which is basically we've got some fancy weather measuring gear, which is temporary at the moment. It's a bit of a project, but over time that needs to build, and that all kind of feeds into that infrastructural piece.
Yeah.
But probably the biggest thing there, which you might have noted I skipped, was the special use airspace, and Mark did talk about this a little bit. So here's a nice graphic of the scale of what Tavki has got over the line. It was a really big job, so we're very proud of it. And this is a tool for the system here in New Zealand, but actually it's starting to get international recognition, which is, you know, where we're talking about what's the positioning of kind of New Zealand Inc. in this space, then you cannot fit special use airspace that big into Europe or America without crossing a bunch of air traffic lines and also shipping lines as well. So that's really, really rare. So that's a bit of an overview of the aerospace side of the problem, at least. Yeah.
Awesome, cool. And yeah, what has the journey been like with Tafaki? Because I think you said it started like before the land was even bought. Like it was something about Rocket Lab needing like a launch site or something.
Yeah, that's true. Which I don't have on here, so I'll go off the left a little bit. 2016, I believe, was the year, and perhaps Mark was involved. He might be able to tell us. But Rocket Lab were doing a survey around Aotearoa to look for the space, which has now become Mahia Peninsula, for vertical launch. And they identified Kaitareiti as actually the primary site in the country, essentially because of the picture I just showed you. So you've got a combination of clear skies, clear space, nothing on the ground, which all goes into your safety assessment for regulations, but you're also close enough that's useful to Christchurch with manufacturing skills. You've got the universities, you've got the international airport, and Lyttelton, obviously, for the international seaport, which is really important for space to be able to move big things around. And there's also an existing kind of connection to the international community with Gateway Antarctica and those kind of things. So that clocked on the opportunity, and it took quite a while to turn into Tafki joint venture, which was a lot of the Mann understanding what is the opportunity and how do we want to be involved, and that resulted in us standing up Tafki joint venture in 2021. And then it's been a wild ride. So in 4 years, we've gone from standing up a joint venture, getting the 1,000 hectares of Kaitareiti back to ownership to the Mann Whenua, so that's really important. Standing up the Aerospace Research Centre, which was a field. And I joined in 2023, if my memory serves, and my first couple of weeks was pushing a residential mower up and down a grass runway. So it gives you a feel for how quickly we've gone from where we were there to now. And then just quickly, kind of the last couple of years has really kind of escalated, I guess. So we went through what we call the foundations, which is putting in that base infrastructure, the runway, the hangarage, and that enables the likes of Kia and Dawn and the other community around us to test. But now we're kind of in that framing stage, which is starting to leverage that to perform the required testing to start moving the system along, which is where that digital stuff comes in.
Awesome. And yeah, so from there, where are you guys heading towards in the future then?
Yeah, got some interesting things coming up. So there's more bullet points than people we have in the team. So I'll just mention we have a 5-person team right now, all the stuff we're trying to do. So we'll see how much of this comes off. But one of the bigger things on the Fenua side, they've been doing a lot of work in the background, and they're going to have a landmark project with getting a footprint. So essentially a centre a bit further down from the Aerospace Centre on Kaiseriti, and that would provide Fano with an opportunity to spend some time on the land. And we're already starting to get quite a lot of academic interest in the environmental and ecology space, which is pretty cool. So we want to kind of give them a home,
Yeah.
We've got another round of physical infrastructure expansion. So that's currently just finishing up the funding situation there. And that will probably look like more hangarage, a few more access tracks around site. And what that provides the system is more capacity for tests. So as soon as we open Faitiri, the hangar we've got now, we have 3 operators all trying to get the same good weather days back to back, right? And people are not able to do what they need to do to progress. So, we need to kind of open that up a bit. Clean energy strategy is an interesting space. That kind of sits perfectly in between our dual co-popper. We need to investigate the clean energy from the aerospace side, and that may look like hydrogen, whether it's production or leveraging what the airport's doing and getting it out to site. But also, we've been doing investigations into on-site generation. So other than hydrogen, that could look like large solar power. It's actually a really good place for that, and that can provide resilience to the local community as well as supporting the activities we've got out on site. And then there's a bunch of, I'd say, kind of project-oriented stuff there. So we've got the meteorological side is spooling up. There's a lot of interest. There's this huge meteorological data gap in the Southern Hemisphere, it turns out. It's about as much as I know about it right now. But, and then all of those kind of above points really lead into the UAM enablement side, which stands for Urban Air Mobility Enablement. And it's really the bit I was talking about before of kind of getting everything together in the air in a safe way, and kind of doing that in a stepwise fashion. Is that all of it? Oh, no, vertical launch. Yeah, there's that whole other arm. That it's not currently our primary focus, but the reason that Rocket Lab picked the space hasn't gone away. It's still a massive opportunity, and we just assess opportunities as they come along on a case-by-case basis. So I imagine at some point that will certainly happen. Yeah.
Awesome. Cool. And is there anything that the audience can help you with today?
Not really. I would say, look, we're here to support you, actually, so I would like to flip that and just say, look, Tafiki's here to help the system along, particularly if there's anyone in the kind of OEM space, which I'd love to see more of. I can echo Mark's comments on that. Come and talk to us. If there's anything else you've seen that's adjacent around the aerospace that you're interested by, we're really here to play a supportive and facilitative role. So yeah, just reach out to us and understand our story, and we'd love to connect on a bit of a deeper level and understand what you're up to.
Awesome. Thank you, John.
Thank you.
Oh, we'll do Slido first. Just let him mess with the computer. No, I can just take that from you if you want. Oh. I have an autonomous drone company. How can I start running test flights in your area, and what does it cost?
Excellent. That's great to hear. Pretty fast work from my question just there of starting up. So, yeah, the process for working with Tafki starts with kind of relationship value alignment, I guess, and that's really the start of it. We do have a bit downstream, but ultimately we start with a conversation, reach out to any of the Tafki team, come and talk to me afterwards. We'll probably exchange an email or two and set up a call. And then we just want to actually understand who you are and what you're about and your values as an organization and as a set of people. From there, assuming it looks good, then we'd start to go through a bit more of a due diligence phase. We'd probably look at the con-ops of what you're trying to do, and we can give you a bit of a steer on the appropriateness of different aspects of our kind of facility and our offering. Sometimes people need that, sometimes they don't. It depends how mature they are. The other speakers in the room can do all of that themselves. Sometimes there are new entrants to the space, and then it might be useful for them to kind of get a steer from us.
Awesome.
I'll leave the what does it cost, that's sensitive. No, it's not, but we're updating our pricing, so I don't want to talk about it here.
Will you need to expand geographically to support future opportunities?
Yeah, that's an interesting one. So in terms of our current land holding of the 1,000 hectares, which was the kind of green bit on that map, that's not the whole area of what our Runanga and Manawhenua 2. So we have this really long-term vision, I guess, multi-generational vision of a mosaic of activity across the whole of Kaitariti. But I'd also say on top of that, this is not a Tafki problem that we're solving. This is an ecosystem, right? So I see it more as certainly a whole Otatahi, but definitely a whole of Etaroa problem. There's going to be a network of different things everywhere. But yeah, for what we want to do, we'll start to leverage different land parcels and create more infrastructure in different places. So for example, you could do point A to point B testing on site, and then, it'd be lovely to extend that out from somewhere on Kaitariti to somewhere else entirely, and that's that kind of pathway out for aerial integration. But then once you mix in the other aspects from the Whenua team working on the energy, sites for whānau to spend time back on their land, we're going to have to kind of dot things around quite a lot. Yeah.
Definitely. Is Tafaki affordable for early stage startups, or are you more suited to funded companies such as Kia, Dawn, Sios, or SPS?
Yeah, it's been quite an interesting change, I guess, over time. The simple answer is, because we're here to support the system, we'll work with operators and their needs. We're a small enough team and we're early enough that we have the ability to customize, right? So yes, we can support you.
Awesome.
It is helpful to have funded companies that can also help with our revenue, because we do need to cover costs. But you can't get there unless you can do some early work and testing, right? So that's kind of the premise. Yeah.
Cool. What capacity do you have for test flights, and what can that be scaled to?
That's a tough one. There's definitely a weather element. It's not like an airport where you can say, here's a fixed bunch of operational limits and here's the weather for the area, because it's R&D. Everyone has their own limits. Everyone has their own infrastructure requirements. Everyone has their own timeframes. So there isn't really a straight answer, to be honest. We have more capacity than we've got now. In some areas, I would say, certainly the kind of runway usage, I think we could up that. I kind of mentioned the hangarage is a bit tricky already, but we've got plans to kind of alleviate that problem. In terms of what it can be scaled to, I think that goes a little bit along with the infrastructure upgrades, but also the maturity of the system, because the safer something becomes, the less one person at a time it needs to be. Yep. So that's part of our goals, and we work with our existing client base and the CAA to start opening up those opportunities. Yeah.
Awesome. And last question. Given you're growing internationally, do you intend to prioritize New Zealand companies, customers, or will it be first in, first serve?
Yeah, we don't, well, as far as I'm aware, maybe the board does. We don't have a set rule on that. I think it's more, at this point anyway, we address opportunities as they arrive, and we just look at everything case by case. And there's actually been a lot of work in the first couple of years while the kind of early spin-up was happening in the foundations of what are our values and how do we run an assessment like that. So we have an internal framework that people go through and all of that. So that helps us make those decisions, and it's values-based, but it doesn't currently say has to be New Zealand.
Yeah. Awesome. Cool. Thank you very much, John.
Thank you.
now it's my favorite time. It's pitch time.
Thanks. Hi, everyone. My name's Murray Hammond. I run a service called, DFM Solutions. So I help hardware teams and manufacturing teams with production issues and project issues. I meet a lot of teams around that have they're having similar types of challenges in production, whether the throughput's not doing what it needs to do, the scrap rate's coming up, or you're just not realising the design that you thought you were. So I can help there. And also with project recovery, often projects get some speed wobbles as they go along, and I can help stabilise and bring a commercialisation project back on track. I offer a couple of basic services. One is a remote production line audit. So if you get in touch with me, we can share some details, and within 48 hours I can respond with a succinct list of improvement and fixes for your production line. Awesome. and then support you for the following 2 weeks. Or you can engage me to help with projects and things like that.
Sweet, thank you, Murray. Cheers.
My name's Thomas, and I work for with a team that looks after all the electronics at Dawn Aerospace, and I actually have a bit of a problem. Does anyone know the name of SpaceX's most recent launch? Was scheduled to happen last night, early hours this morning. Do anyone know the name of it? Transporter 17. And that number is significant because Dawn's been on nearly every transporter mission since it started. We didn't miss one until Transporter 14. Nearly everyone. Now that's proven to be a bit of a problem for us because it's quite a demand in the electronics front, trying to produce electronics that are capable of flying on transporters and surviving in space. So currently we have 140 bits of hardware above our heads at the moment. 40 of them are across different satellites. Some of them are on the way to the moon, some of them are on the way to an asteroid, and we really need help on the electronics front. So if designing and building looking after complex electronics and preparing it for spaces for you, come talk to me.
Sweet, thank you very much.
Yeah, hi, my name is Miguel. So I recently graduated electrical and electronics engineering at the University of Auckland.
Woohoo.
Yeah, I went to the summit, liked it so much that I'm here. I'm back here for a short vacation. While I was at university, I worked on the avionics for a 1U CubeSat. I eventually did assembly, integration, and testing. So I did spend a lot of time doing things like thermal vacuum testing, random vibration testing, and those sorts of things. I also worked on the power system for another CubeSat that's coming out of the university at 3U with really harsh volume constraints, really fun stuff. Currently, I'm working with the power electronics group at the university on inverters for inductive power transfer. Yeah. Also a huge space nerd. Spend way too much time stargazing. Hobbies. I also do photography, videography. Yeah, it's me.
Is there anything that they could help you with?
Oh, yes. Forgot the most important bit. Looking for a graduate role, junior role. Yeah.
Awesome.
Thank you.
Sweet, thank you very much.
Hello, everyone. I'm Renato. I'm a space lawyer. Yeah, space lawyer.
Space lawyer.
Space lawyer, yeah. I've been working for more than 6 years back in my country as a lawyer in Mexico. Now I just finished my specialization in the space lawyer, and I'm already using all this knowledge, running a platform, trying to explain normal people how that complex stuff works with easy works. And at the end of the day, what I'm looking here, I'm looking for opportunity. I'm looking for a company who can help me starting professional in this pathway for me. I'm looking for a chance. I'm looking for a chance to show you that you do the right investment, and I'm looking for a job as a space lawyer. If you know someone or you need someone in your company with this profile, 6 years experience working as a corporate lawyer and a lot of committed for this. I'm here. Thank you.
Awesome. Thank you.
So for those of you who came to this hardware meetup last year, this won't be the first time you've heard me say this. We are once again hiring. I work for Asteria Engineering. We make aerospace electronics. We do things for companies in this room, and we also seem to be New Zealand's leader at putting things on the International Space Station. So if you want to build stuff that's going to the International Space Station next year, come talk to me. Thank you.
Excellent.
Hey, my name's Hamish. I just think I'll take this opportunity to introduce myself to you guys. So I'm from a mechanical background, and I'm designing big, great automated machinery. And so I found this problem with timber framing for residential construction, and I think I can automate the assembly process for it. So we've got a prototype working, and it's going really, really well. And so I guess it's just, if you're interested in talking about construction or anything to do with automation in the space, come reach out. Really interested to talk to you. Cool.
Awesome. Thank you.
Hi everyone, I'm Xander. Currently an undergraduate at the University of Auckland. It was my first time in the South Island about a week ago. I'm here currently working an internship at Air New Zealand as a design engineer. I wanted to talk about the student club, which I co-founded last year at the University of Auckland. It's our first ever rocketry club. We're aiming to go to Australia this year. We currently also are looking at trying to build hybrid powered motors, much like how UC have done it. Auckland's lagged a bit behind in that. If anyone here is interested in building a student connection with rocketry in space, especially at the biggest university in the country, please come talk to me after. It'd be awesome.
Hello everyone, my name is Martin. I'm a freelance mechanical design engineer. I'm focusing on developing hardware, building prototypes and such things, and bringing people's ideas from paper scratch into production. So if you have some project, something interesting, let me know. And plus, I have my own startup. I develop a motionless wind turbine. So if you want to support me or just give me a hand with this project, it will be pretty cool. Thank you.
Awesome. Joining me, Scott.
Cool. Yeah, it's great to be here. I'm Scott Spurner. I'm the CEO, which is average, but more importantly, the CTO of SPS Automation.
Awesome.
Nobody likes the business. Making stuff is cool. I thought Mark had a really good idea, and he asked, who knows who we are? Who knows who SPS Automation is, or has heard of us, or worked with us, or cool.
Excellent. So what does SPS Automation do?
Okay, so we do a lot of things, but our primary stuff is design and manufacture of bespoke robotic systems, mostly in aerospace, the aero part. Drones, drone technology, autonomous vehicles, autonomous aircraft, but we've also done ground robotics, automation systems, smart systems that go onto manned aviation, all sorts of stuff. So we do a lot of this. We have 3 different facilities, one here in Christchurch that does all our R&D, a production facility based in Timaru, and then a maintenance facility and service sort of system up in Auckland. So we sort of cover nationwide for all the different kind of things we do. There we go, there's a picture.
Yeah.
On top of doing, I guess, what you call contract R&D, concept to commercialization, we develop our own products, and we specialize in agricultural drones that are to go out and spray invasive plants. Wilding pines, gorse, nacella tussock, all the stuff that you don't want in our beautiful environment, we want to get rid of some of that.
Yep.
We try to make these systems autonomous. It's a challenge. There's lots of regulatory hoops that you have to jump through. So we do a lot of aerospace stuff, but we also do a lot of work supporting the aerospace industry. We have 2 experimental aircraft testing sites, which allow us to fly unlisted large aircraft, which are experimental. We have one here in Christchurch and a 7,500 hectare site down in Timaru. And that's really cool because we can do things like beyond visual line of sight testing of range systems or drones. It's all sort of this is actually here, undulating terrain, forestry, and we've also got mountainous terrain. So kind of that complex inland test all sorts of different types of environments in drone technology.
Awesome. And then, how do you make these drones, and how do they work?
How how do they work? That's complex.
Agreed. You have to answer it now in like 30 seconds.
Cool. I mean, yes, yeah, how are our products made? So our drones are hybrid. They run on fuel rather than batteries. Most agricultural drones, for what we do in spraying, they fly for about 4 to 10 minutes. It's designed to, most ag drones are imported from overseas, primarily China, the main leaders. They come to New Zealand. They're designed for doing broadacre spraying, so take off in the paddock and dump as much chemical as possible. Spot spraying is what we focus on. It's our niche. We want to sort of be able to fly into the hills, and basically everything available, it would run out of battery before it would get there. So we developed a whole hybrid system, which means that they run on fuel. We have multi-fuel engines as well. They generate electricity or generator on board, and then we power a traditional electric propulsion system. They're all made here in New Zealand. Most of them, all the R&D prototypes are made here in Christchurch, and our production facility is down, in Timaru. We try to use all New Zealand manufactured components. We can't get quite everything, but we've moved a lot of the manufacturing from overseas to New Zealand, including our electronics PCBs. We do in-house software, all the electronics, design and manufacture PCBA as well. We try to make our composites in-house. We've got CNC machines, we've got things that cut, things that shoot lasers, things that spin, widgets, all sorts of fun stuff.
Awesome. And I think you mentioned, so you have the spraying drone, but like you also have kind of a business model about how to fund that as well with more custom.
Yeah, so I mean that's a bit about our journey, but like when we first started, which was about, here we go, journey. So we're about 6 years old. We sort of started off with me and my garage, and it was pretty clear to me that R&D is expensive, and I wanted to build some pretty big, cool stuff. We have two products, our AC-16, which is there, and our BFD-70, it's big, friendly drone. That's our sort of flagship aircraft. And to build that, you need a lot of funds to do all the R&D iteration. So we looked at how can we fund this, and that's where we sort of expanded out to do contract R&D for other companies. So instead of going out and getting Series A funding and, angel investors and taking a bunch of money with cash burned to the bottom and hopefully finish, we sort of had this smooth sail along the route where we could do R&D work for external partners and use that money to feed back into the development of our aircraft. So yeah, we're about 6 years old. We started in my garage, just me. We got to about 7 engineers working out of there before my wife was like, get out. And now we've got a really great facility right here in Christchurch. It's pretty big. I've got a team of around 17 engineers, and that's just in the Christchurch base. And then we also have our production and maintenance facilities.
Awesome. And so when did you release the first one?
So our aircraft...
There's two.
There's two. Our aircraft are brand new. The AC-16, which you see here, we've sort of been taking orders for about 2 months now. So it's brand new to market. It has a 1 hour flight time, carries around 16 litres of chemical, and that allows us to do spot spraying of wilding pines. That's our key. It's a wilding pine killing machine. We did a job down in Central Otago recently as a trial, 500 hectares of wilding pines, but sparse, like 1 per hectare. You can't really spray that with helicopters because it's just not financially viable, but also it's way too spread out to send in ground crews, and the terrain was not really safe. We were down there for 2 days, whereas ground crew would take weeks to do that area. I was sitting in my truck flying the aircraft around, spraying these trees, and the council was paying $36 a tree, so that's like 10 grand for 2 days' work sitting in my truck flying a drone. Pretty nice.
Awesome. So that one has been released for 2 months now?
Yeah, it's roughly about 2 months we've been taking orders. We've been building the first batch in our production facility. A really great machine. Even though it's been around 2 months, it's actually about a year of us operating this aircraft.
Yep.
So we don't just finish an aircraft and go straight to market. We have our pilots doing operations, doing trials, testing these things out, because a trick for startups is if you think you've finished your product and you release it to the market, guaranteed your first clients will break it immediately and it's going to be a bad time. So we always try to test everything as thoroughly as we can before they break it.
Yep. Awesome. And then, so you've now got a new model as well. So yeah, what's the future heading towards?
Well, we are expanding. I mean, we've just taken more building. We've been growing our R&D facility and our production, including doing external jobs. So we've been building other projects like drone light show systems, some flying machines for universities. But as we're sort of growing, we're going to be offering like leasing capability of our aircraft. We're doing training, maintenance training, growing into all of the support areas around the aerospace sort of facility. There's one thing to make a drone and then sell it. Another thing to be able to support that moving forward. These are aircraft. They need to be looked after. They have to be maintained in order to be airworthy. We, as well as doing all these things, we are a approved airworthiness assessor for the CAA for helping companies with something new or something they've brought into the country to go through some type of standardised airworthiness first type testing for the support of for including that aircraft in a Part 102 operator certificate. We do maintenance, documentation for people, it's all sorts of stuff. So anything related to drones, the aero part of aerospace, from a lot lower than what most people in the aerospace industry work in. That's kind of what we've been doing. And when it comes to vision, it's not just about making cool stuff.
Oh, sometimes.
A big passion of our company is actually to grow the industry, the manufacturing capability here in New Zealand, create jobs for young people. When I was at university, I studied mechatronics, and I was like, what do you go and do when you finish your degree? And my idea was to build a company that represents what I thought you would do as a mechatronics engineer when I was studying. So, we've been building some really crazy machines. It's very exciting to get out there, build them, to do all sorts of fun stuff.
Definitely. And I think when we talked earlier, you said this is actually like 4 meters wide or something?
Oh yeah, the BFD, big friendly drone again, yep. So that's what it looks like. I didn't actually put any current pictures. We're flying this machine now. It's
You had your first test, big test the other day?
Yeah, big test, big milestone test. So this is a 350cc opposing twin fuel-injected two-stroke engine that produces, generator that produces around 16 kilowatts of electrical power, which is a lot to deal with when you're talking about PDBs and rectification and all that fun stuff. We also have a 225cc Wankel engine that does about 24 kilowatts of power, and we use that to power a monster machine. This carries 50 kilos of payload. It flies for 2 hours. It has satellite communication, Starlink on board, so Starlink dish in the aircraft, cellular connectivity, 2.4, 5.8, and optional 1.4, depending on where in the world you are. ISM based, so all multi-different levels of connection. The machine is designed around teleoperation and what we call one-to-many, where instead of having a pilot standing in a field flying a single drone, you have a command center with expert pilots operating numbers of drones around the country, because it's not actually just about, it's not about the pilot on the ground. It's about pilots these days. It's not Top Gun anymore. It's not hold on, It's about making the correct decision if the air risk or the ground risk changes during the operation, and having that abstracted from the person on the ground who may have, stress bias in a intense situation. So all about aviation safety. Make the machines smart, make them do the jobs themselves, and then remove the pressure from the ground to allow these machines to operate in the areas where you just can't see people.
Yeah. Awesome. And I don't know if you mentioned, how heavy is that drone?
It's 160 kilograms, flying weight, 4.5 meters. It's a multi-rotor, which is, I mean, well, when you say 4.5 meters, planes are like, fixed wings, a lot bigger. We've got Kia here who's got some monster fixed wings. But for a multi-rotor, and when you fly it, it's incredibly intimidating. But yeah, there's a lot of engineering has gone into the machines and products that we make. And I mean, I'm actually just backed by a really incredible team. It's the engineers that actually get us through. I just come up with the crazy ideas on what we want them to do.
Awesome. And is there anything the audience can help you with today?
Look at that big hand. It's not my hand. Yeah, well, as a company, we aren't in need of real help. But what I kind of wanted to say is that I wanted to challenge the people here, invest in the future of engineering, bring interns into your companies, support young, smart people, because that's where engineering is heading. We always try to take as many interns as we can, train them on real projects, real complex stuff, throw them in the deep end really, and invest in sort of the future of that. As well as investing in young people, get involved with universities, STEM as well as a great outreach. Buy New Zealand made, get things made here, build New Zealand manufacturing. New Zealand's always been known for innovative designs, novel ideas, number 8 wire fixes to really complex problems, and we need to grow that here and bring some of the manufacturing capability that we've struggled with lately because it's so cheap to order things from overseas. You can just put it in a cart and it's here. Get it made here by people here and grow the industry.
Absolutely. Awesome. Thank you very much, Scott.
Cool.
I'd just like to add to that last point you made. In Auckland, at the moment, your students looking for internships, they can't find them at all. It's a really, really big problem. I'm not sure if it's similar in Christchurch right now.
Yeah, it's been pretty busy. We took 5 this year. They're doing some really great projects. One's doing a 360-degree FPV augmented reality flying headset.
Awesome.
And the other one's building a docking station that measures different chemicals by itself, so the aircraft can dock and measure these chemicals. And the way we run our internship projects is I'm the customer. I pitch them the same way that we would receive from our clients, and they've got to, pull the requirements out of me, define the scope, pitch the scope back to me, go through the same design process with design review with our engineers. So that's how we like to run our internships, and then build the thing.
Yep.
So, yeah, we always run our internships the same way that they would experience if they were working for us as engineers.
Yeah. That's a really great design for a program. I haven't heard of an internship program like that.
Make cool stuff.
Yeah.
Cool shit.
Yeah, exactly. Awesome. How much of your revenue is contract R&D versus product sales of drones versus services running the drones, i.e. spraying?
That seems very confidential.
What percentages?
Okay, I mean, we do have shareholders as well. They help us through the dips. We try to, ultimately we try to be net zero, so the cost of our R&D is matched by the cost of our development and running the business, and all the overheads is matched by the R&D work that we do for external parties. Spraying, we don't do a lot of actual contractor spraying work. We are going to be ramping that up in the coming future. Most of our spraying work so far has been trials where we may either do it pro bono or at an extremely discounted rate, because engineers make pretty expensive contractors.
Yeah.
So yeah, it's a mix. It can go up and down from month to month to year. I don't actually know the balance, but we're still here, so that's right. And growing, so.
Yeah. What's your next crazy idea to integrate into the company's operations? That might be confidential.
Crazy idea. So I've got a bunch of, we have a roadmap of all this fun stuff that we're going to be doing, but I think the craziest one is I want to use big lasers to kill plants from drones. Herbicide alternative invasive plant control. What happened, we're all about New Zealand and our environment and our people, so let's stop putting so much chemical into the environment. What if it's an organic farm? You can't use chemical. How do you control the weeds? Lasers are cool.
I'm curious about the safety regulations around that.
So we have done some tests, and I can confirm that we have used a laser that will cut down a fully grown pine tree from about half a kilometre away, but there is some fire risk, human safety, danger, and I'm not quite sure what the public perception if I hook it up to an AI model.
By the way, this has been live streamed.
Excellent. Cool. Is that all you have to answer that question? Oh, it looks like it was. Have you looked at firefighting and search and rescue? Or maybe you're looking at creating the fires, I'm not sure.
Well, it's just like this, you see.
Need to get the money in somehow,
So I can't really say too much other than watch this space.
Cool. Good
It's
answer.
really tricky because we have our aircraft that we manufacture that are our products, but a lot are really great ideas from other New Zealand companies. And I can't say what we do because it's all locked down under NDA, but it is a fun place to work.
Because a lot of people come and approach you being like, can
Yeah,
you make
we're
this thing
just
for me?
like the little cogs in the background that might be the avionics side of things or the control systems or how something will work, or if they might have a mechanical shortage, an electronic engineering shortage, and they want us to integrate just a part of their system through to ground up project builds.
So you get your fingers in all the pies, basically.
Yeah.
Lots of cool pies.
Yeah. We've got machines in the meatworks industry, we've got machines in the agricultural grain industry, we've got machines in universities, stuff with the CRIs, working in the bees industry, and then drones, lots of aerospace stuff, mostly aerospace stuff.
Awesome. Is there a limit to the size of the drone you can make, i.e. like a regulation limit?
I reckon there's probably more of a financial limit. So obviously with all drones, aerospace, it's all governed by the CAA. There is a very complex regulatory system that we work through. Our stuff is governed under the Part 102, the Civil Aviation Rules Part 102. They've now just released 107, which I think is coming out next week or next month for experimental stuff. Our experimental test zone here in Christchurch and Timaru, we are allowed to operate an aircraft up to 8 metres maximum characteristic with a 75 metres per second maximum flight speed with no weight restriction.
Cool. Probably the last 2 questions now, so get your votes in. What role do you think drones will have in the agricultural space going forward, and what are the challenges that we need to overcome?
I think a lot of the agricultural use will become autonomous. You say drones, and we sort of talk about what you normally think of multi-rotors or fixed wing, things that fly, but autonomous tractors, autonomous vine eating, cleaning, pruning machines, technically they're drones. Autonomous systems in general are rapidly rolling out in the agricultural sector. There is a lot of risk in these sectors. Farmers get hurt, people get hurt. Robinson helicopters fly into hills all over the country sometimes. So from the actual drone space, I see within sort of 10 years, most of the agricultural application of fertilizer, chemicals, and lasers maybe, will be through autonomous vehicles, whether that is a multi-rotor or a Robinson helicopter with an autopilot, it's all going to be remotely piloted, removing a human from the risk of operating at low altitude.
Yep.
Yep.
Awesome. And last question now. Have you considered an open source hardware strategy to scale your supply chain and distribution?
Maybe. Is the person who asked this in the room? Explain.
So, you're talking about sovereignty, building the ecosystem here in Aerospace.
Yep.
And if everybody holds on to their own platform,
yep,
then the fragmentation would be enough on our chain.
Yep.
So, in terms of scaling, at least the domestic supply chain and countries that aren't the US and China, is that something you contribute? Maybe just like your last model up to
Yeah, I mean, we try to do as much with New Zealand companies as possible, outsource that manufacturing. Like on the BFD, all the titanium nodes are made here in New Zealand. We use CTEC for carbon. We do our own manufacturing, and then our production facility and all of our tools that we have for making cool stuff, I quite regularly, hopefully our shareholders are not watching, let other businesses come and do little bits. You know, I'm all for community manufacturing, I think is a better way of putting it. I'd much rather work with somebody that I can walk down the road with and have a beer after we've made the thing.
Awesome. Cool. Thank you very much, Scott. Sweet. Yeah, really awesome turnout. Thank you so much to everyone for coming. Thank you very much to our amazing sponsors. Thank you to Epic for hosting us here. So thank you to Loon Digital, Aerospace New Zealand, Invenio, GPC, and Christchurch, New Zealand. Yeah, and thank you all for coming.